Okay, so I'm going to have a little look here. I'm going to show you how to investigate what happens to the coordinates of a point when we reflect it in the line y equals x. So basically I created a point here and I set it to have its coordinates showing. You do that via the advanced setting here, and that will give you the choice of showing the labels. Anyway, so let's put a line in. And we'll put the line y equals x. In fact, I'm going to do it via the input bar. So if I just type here y equals x, there we go, we get the line. And you can see it's appeared up here in the algebra bar here. Now, I'm going to select the reflect tool, which is this one here. We've got a whole load of transformations there, but it's reflect object in line, which is what I want. So it tells me how to operate it. Select object to reflect, then the line of reflection. Okay, so we simply select point A and click, and the line of reflection and click, and we get the point A dash. Remember that the original point is labelled with no dash, and then the image of that point is labelled with a dash. Some people say point A and point A prime. Now, can you see what's happened to the coordinates? Okay, now, hopefully you'll have spotted that the x-coordinate of A has become the y-coordinate of A dash, and the y-coordinate of A has become the x-coordinate of A dash. But was that just a coincidence? Maybe that was just a bit of a coincidence. Now, let's try putting some other points on, and we'll also reflect those points in the line. Let's go for one down here, 1 minus 1. Okay, now you notice it hasn't got the coordinates showing. It's because I haven't told it to. If I wanted to, I could go in there and change the properties. Now, we're also going to reflect that point in the line y equals x, and we get the point B dash, which has got the coordinates of minus 1, 1. So 1 minus 1 has become minus 1, 1. So again, the x and the y coordinates seem to have been transposed, or seem to have swapped positions in the image. Now, how can we tell if this is just coincidence or if this is a general pattern? Well, we could keep on putting points on the line. Now, notice that if I create this point and then move it onto the line, now I don't need to reflect that point because any point on the line is its own reflection. We can just confirm that, if you like, by selecting point C and then reflecting it in the line. You'll see that C and point C are actually coincident. They're the same point, and they have the same coordinates. But there is a better way of doing this. Now, what I can do is take point A and move it around, okay, and then keep your eye up here in the input pane and just see if the relationship holds. That the x of A becomes the y of A dash, and the y coordinate of A becomes the x coordinate of A dash. I'm going to simplify things by just deleting B and C and their reflections, okay? So watch what happens. Okay, the relationship seems to be holding. Again, seems to be holding. Keep your eyes up here in the algebra pane. See, it seems to be holding. And on the line, yeah, it certainly seems to be holding. Okay, so although it's not a proof, it's a demonstration that that relationship holds for all points. Now, I'm going to stop there, and the next video I'm going to show you what happens if we reflect a line in the line y equals x.